Question: does this function, this one here, does this function have a horizontal asymptote? Well, first off, what's an asymptote? If you have a graph that's like this, no, like this. See how it sort of comes closer and closer and closer to the x-axis, but never touches it. No touchy. No touchy. Let's say the x-axis would be the asymptote. We would say the graph is asymptotal. The graph is which graph? This graph. Which graph? You get burned at the stake for that. This graph. Which graph? That graph is asymptotal. Asymptotal to the x-axis. It comes closer and closer to the x-axis, but no touchy-touchy. In other words, as you move along this graph, this f of x over here, in this direction towards infinity, towards the right here, towards infinity, what could you say? You'd say the distance between the graph and this x-axis, between these two guys, what happens to it? Well, the distance between it and the x-axis eventually becomes smaller than any distance that you can point to, that you can say, that you can describe. Yes? It becomes so small, you can't specify the distance anymore. It becomes so utterly, completely small. But no touchy. So the x-axis equals a linear asymptote. And that's an abbreviation. You could say run out of room. It's a linear asymptote. And that means it's a straight line to which a graph, this guy, gets closer and closer and closer to, but they never become the same. No touchy. They never become identical. No same. So the x-axis is what? In this case, it's a linear asymptote. And this graph is coming closer and closer and closer and closer to this straight line, but never touching it as they move towards infinity. Okay, now let's go back to our problem. Does this function have a horizontal asymptote? Does it have an asymptote that's horizontal to it? Well, let's find out. Let's find out algebraically. This guy has two parts. I'm sorry, what does he have? He's got two parts. He's got 5 times this guy. Yes? All right. That's part number 1. And this will be part number 2. Let's look at part number 2 for a second, because you can't do anything with part number 1. I mean, 5 is 5. There's nothing to evaluate. But over here, oh, there's something to eval, all right. What if this problem were different? What if we wrote this as not 5 times 0.08 to the x power, but put 0.08 in its decimal form? Well, that would be 0.08, 1, 2, that's 100, that's 100ths, 10ths, 100ths, so that's the same as 8 over 100. Ah. Oh, there's the equivalent of 0.08, 8/100. I can reduce that to divide by 4 into 8 goes what? 2 times. 4 into 100 goes 25 times. Reduce that further, that's about 1/12. I'm going to approximate so we can do this easy, so you can see this much more easily. So I can rewrite this now as 5 times 1/12 to the x power. Oh, let's do that. That's fun. All right, so I'll say 5 times 1/12 to the x power. So as x goes to the right towards infinity, good, that's a good one. So as x moves this way, what happens to our 1/12 raised to the whatever x is? Well, when x is equal to 1, y is equal to 1 to the 1 power, 12 to the 1 power, that's itself, 1/12. When x is equal to 2, 1 squared is 1, 12 squared is 144. Oh my goodness, it just got really super duper small. When it gets to 3, I got to move it over here because of space considerations. I got 1/12 to the 3rd power. Oh my goodness. Let's get out the calculator. For 12 times 12 times 12 equals 1728. So now 12 to the 3rd gives us 1,728. These are getting really super duper what? Small, eensy weensy small. 1/12, 1/144. Are these getting bigger or smaller? They're getting smaller, really small. How fast? Super duper fast. And they're coming closer and closer to what? 0. Right? 1/12, then smaller, 1/144th, then really smaller, 1/1728. This is super duper small. And this is happening with each passing of x. As x goes to the next value, from 1 to 2 to 3, wow, these are getting fast. These are getting small, and they're getting small fast. Essentially, what's happening to our guy here? Well, let's replace the 0.08 with its equivalent. Now, let's evaluate this now. We've got 5 times something that eventually will come so close to 0 that eventually it's just about 0. Tell me, what is 5 times 0? And the answer is 0. Ha! Ha ha ha. This function is approaching, never touching, but approaching 0. What is it approaching? 0. But it's what? It's never touching 0. So we say that y equals 0 is the horizontal asymptote. Notice in performing this operation, we are multiplying 5 times what? Times what this is becoming. And we get 0. Y equals 0 is our horizontal asymptote. That's it. I'm out of here. So long now.